So this is Chapter 5, Section 3, and in this section we're talking about the conservation of energy. And we've got about 10 or so slides to go through. So when you say the word conserve, it's talking about to remain constant, and specifically here we're talking about energy. So far we've ignored air resistance, but if you weren't to ignore that or friction, then you would have to include that in here. For mechanical energy, it's the sum of all the kinetic and all types of potential energy that you have for a group of objects. It just depends on what you're studying. And when we look at this, you see the sum sign there. Looks like a large E, but you can also look at it as initial mechanical energy equals final mechanical energy. And this is going to be in the absence of friction. So I want you to see how this is also going to look if it's broken down. What did it say made up mechanical energy?
Kinetic energy and also potential energy.
So a common way of looking at this for your kinetic energy, what's the formula for kinetic energy we talked about? Okay. This is the initial side. And if you look at all the sum of your potential energy, what is gravitational potential energy? Okay, mgh, and that, again, it's going to be initial height. And what is your elastic potential energy?
1/2
kx squared. When you're looking at this, and we're going to go through some sample problems today, and you're going to have some for your homework, you might not have gravitational potential energy, you might not have elastic potential energy, but they're there, and if something cancels out, just mark through it. Especially, too, based on heights for your elastic, and even the X is based on height there for elastic potential energy, or H for your gravitational potential energy. If you're at your 0 mark, depending on how the question is asked, chances are you're going to have several parts that are going to cancel out of this equation. Do y'all have that written down?
Is the sum of the kinetic energy and all the forms of potential energy associated with an object or group of objects. In the absence of friction and any other external forces, the total mechanical energy remains the same. This principle is called the conservation of mechanical energy. Consider a pendulum of a clock swinging in the absence of all forms of friction. At each position of the pendulum, its mechanical energy is the sum of its potential and kinetic energies. At its highest point, all its mechanical energy is in the form of potential energy. As the pendulum swings, some of the potential energy is converted into kinetic energy. At its lowest point, all its potential energy has been converted into kinetic energy. As it reaches its highest point again, all its kinetic energy is converted into potential energy. It does not matter what position you choose, the sum of potential and kinetic energies is a constant value. The mechanical energy is conserved.
Make sure you make some notes about this too, as far as the pendulum that they're talking about. At the highest point of the swing, how would you describe the mechanical energy at the highest point?
all the kinetic energy has been converted to potential.
All of it's been what?
Converted to potential.
Okay.
So it would be 0.
Well, at either one of these points right here, your potential energy is at its highest point and kinetic energy is what? Okay, it's going to be 0. And if we look at the lowest point here, how would you describe the mechanical energy? Kinetic energy is at its high, and I'm sure you'll have some values to give it an actual value. And what about potential energy?
0.
It's 0. And then they picked a point that was in the middle. If you pick a point that is here in the middle, right here, that's whenever you get your mechanical energy is the sum of all kinetic and all potential energy. And so you would have values for both kinetic and potential at any of those points in between your high and your low.
That's all. So that's all mechanical.
Every point is considered. You've got a certain amount of mechanical energy at every point. It's just you have to remember that mechanical energy is made up of kinetic and potential energy. So at each of those points, since it's the sum of both, you have to figure out, well, what is my potential energy at that point, what is my kinetic energy at that point, and add them together. So at any point between your high and your low, you're going to have an actual value for kinetic and potential. That's, something that's not 0. So let's look at a problem. It says, starting from rest, a child zooms down a frictionless slide from an initial height of 3 meters. What is her speed at the bottom of the slide, and assume she has a mass of 25 kilograms. So as I'm looking at this, I'm definitely going to, y'all can keep your PowerPoint on this slide. We're going to go and look at how to solve it. What was given?
Initial height.
What was the initial height?
3 meters.
Okay. What else is given?
Initial velocity.
I heard two different things. I heard mass was 1. What was the mass?
25 kilograms.
25 kilograms. And what else was given?
Initial velocity. What
was the initial velocity?
0.
Okay, so VI is equal to 0. She's going down a slide. What's her speed at the bottom of the slide? At the bottom of the slide, what is the height going to be? The final height. It's going to be 0. And it wants us to find her final velocity. So as I'm looking at everything, that's everything that I would label. So I've got H, M, and V. What are we going to work with? Do you have kinetic energy going on here? Okay. There is kinetic energy involved. I'm going to put delta V there because that's final minus initial. Do you have any potential energy? Which type of potential energy in this problem? Definitely gravitational potential energy. Is there any elastic potential energy here? No. No type of elastic potential energy. So when we're looking at this, think about the equation that we had up here on the board. It doesn't matter which side you put final and initial on, as long as all of your data that you have, keep it consistent with whatever side you put your F and your I on. Because I think when we had it on the previous slide, they were reversed, but it's not going to matter. Breaking this apart, kinetic energy, that was 1/2 mvf squared plus mgh final. And then initial mechanical energy, that's 1/2 mvi squared plus mgh initial. Does any of this stuff cancel out? I see initial velocity is 0 meters per second, so that's going to cancel. Height final is also 0, so that's going to cancel. Anything else? I don't believe so. So at this point, you need to actually plug in your values. You got mass. You should know what G is. You know what the initial height is, and now you're solving for V sub F. So y'all plug in your data and come up with an answer. Anybody else already get it solved? Okay, you agree with 7.7? Okay. So not too bad. I'm just going through the rest of this so that you can see how they solved it on the PowerPoint, but y'all can go through that yourself too. Pretty much what we did. So what we've done up to this point, we've ignored friction, but mechanical energy, it says, is not conserved in the presence of friction because what does friction create?
A backwards force.
Okay, it is a backwards force. It also creates a different type of energy, whatever we call heat energy or thermal energy. And it's telling you, in an example, if you took a sanding block and you slide it on a piece of wood, energy in the form of heat is dissipated into the block and the surface. How many of y'all have sanded something and then felt of it after you sanded? What is, besides it feeling smoother, what else does it feel like? It gets warm. It's going to get warm. We're going to go over some more examples because that's the end of this section. So we've got at least a couple problems that we're going to go through, the first one and the second one. Go ahead and work on the first one first that deals with the bird, and then we'll look at the second one that's dealing with the diver. Make sure on your page you're showing all of your work. Do number 1 first, and then we'll do number 2 after that. So don't forget to take the square root if you forgot to do that. So final answer 20.7 meters per second. Anybody have a question on the first one? Drew? So again, in the first one you did have one part that cancels out, and the second one you had 2 parts cancel out since you're going to the surface of the water. Does anybody have any questions on setup? Who's got questions on how to put in their calculator?